Alright, so if you have a cosine curve, right, and it might not be the best drawing in the world, but how can we actually determine the velocity at a certain point? Let's say it starts at x equals x0. Not bad. And we know that right on here we have the mass coming down, right, as mg from the center of mass. The question is though, how are we going to do this? Well, what we can do, we can ask Newton. He might say no, so in case, you know what we'll do? We'll use energy methods. So what we'll do right now is we'll look at it in terms of the energy before, the kinetic energy, a half mv0 squared, and then plus mg, and then y of x of the initial one. Again, I apologize for the terrible handwriting. And then that's going to equal the energy after. It's got to equal that, right? And then you're going to do the same thing. mv squared for the velocity later on, or kinetic energy. And then the same thing for mg, and then y of x. That is unbelievable. And we have that. Again, it's not great handwriting, but we're getting there, aren't we? And then what we do is we solve that. But how do we solve that? Well, we know that y, what is y going to equal? What is y of x in general going to equal? We'll call it a general thing of a cos of kx, right? Like that, right? And what we do now is we just sub it in. That's what we do. That's what we want to do. A half mv0 squared plus, then you have the mg times by the y, which of course is this new value we have for cosine. It is a cosine curve after all, even if it's badly drawn. We're trying our best. We do that, and then we make it equal the same thing for the kinetic energy and potential energy after, at the point we're trying to calculate. That's what it's all about. Add mg a cos of kx. Now, isn't that absolutely beautiful handwriting? And basically with that, what we do, we divide everything by m, and then we rearrange it to get v. Now, I'm not going to go into crazy detail because this is a short video. What we do is we get v squared, finally in the final form, is equal to, and then you rearrange it to get v, you divide by m, times it by 2, and rearrange to get initial v squared, the initial velocity, add 2 times by gravity, times by a, and then in a bracket, we all like brackets, we're going to have, of course, cosine of k x 0, like that, minus cosine of kx. And that is the final form. Even if it's written in bad handwriting, that is the form we have, v squared. We can square root it to get the velocity at that point. So energy methods make life easier. You don't have to try and create a tangent to make this more complicated. Let's keep it simple.